don't mind. Okay, so first of all, so let me thank also for your very kind invitation, and I'm very happy to start this afternoon now with you and before this very large audience in introducing you into the food contact materials and the interactions with the food. So as was already said, I'm coming from AgroParisTech, who is member of the University Paris-Saclay, which is now the largest university of France. And I'm working in a research unit which is called SayFood, and this is now also the largest French research unit concerned with food and bioproducts engineering. The idea here is to work on the eco-design production of food products by the mechanistic and dynamic understanding of these complex systems, and in taking into account the expectation of users and the sustainability criteria. That's why I'm now also directing this chair, which is a chair of patronage called CoPack. And here I'm working across the whole supply chain in order to make eco-design of food packaging and taking into account all the needs of the different stakeholders of the value chain. And what is more closer to what we are going to speak about today is that I'm also working inside a project which is called SafeMat. And this project is a specific structure concerned with the safe design of food packaging materials. And it is mainly based on the methods of mathematical modeling. So my pleasure is now to take you through the food contact materials as a short introduction, and then to give you some background on the interaction between food packaging and show you some challenges, which are mostly challenges now from the European side, which are linked to the place of food packaging in the circular economy. So food packaging is an active partner of the supply chain. As you all know, agricultural products are seasonal, and they are mostly produced very far from their consumers, which means that the packaging needs to help transformation and logistics and bring in one point the food product to his consumer, and during this logistic transport ensure its quality and also its safety. And this is then going to be certified also by what you very much know, I think, the used before and the best buy dates. There is a lot of things which can induce food spoilage, which can like spoilage by biological aggressors like insects or microorganisms, but also contaminants by particles or other external contaminants, and things like oxygen ingress or water vapor exchange, for example. That's why the food packaging here is here to protect the food from all of these. And then you have these four big functions of the packaging, which you can find in any textbook. We are now the transport of the food, its partitioning, the conservation, and the communication. So more precisely, the conservation is then a protection against the mechanical impact, the protection against the microbial, chemical, and physical contamination of the food, but also not to forget the protection of its sensorial and also nutritional quality. Design issues are linked to the communication, presentation, and selling of the food, because it is in fact the packaging which in most cases is going to sell the food, and is also going to inform your consumer on all the legal requirements. And design is also very important for having a packaging which is easy to use by the final client. And today, more and more design is needed also to decrease the ecological footprint, either of the packaging in itself or of what is called the total service offer, which means that this is the product plus the packaging. And basically, this will mean that the packaging needs to ensure decrease of the food losses. To achieve all these functions, a packaging system has developed, which is consisting of the primary packaging. This is the packaging which is in direct contact with the foodstuff. And I wanted to remind you here that you see a bottle, but it is not only the bottle. You have the body of the bottle, but you have also often a label fixed to it, and then you have a closure. And the closure technology are not going to be needed to be neglected, because a lot of quality and also security issues can come, in fact, from the closure. Then often you have not a bottle which is directly sold to your consumer. So the consumer unit is going to read the bottle inside a secondary packaging, which can be a cardboard box. And then this cardboard box can be in the transport in bigger boxes, packed on pallets. And when you make like a mass balance, you can find that those transport boxes in mass, there are more important. So it's more than 50% of the packaging materials are used inside here in the B2B circuit, and only the minor part is used in the B2C circuit. When you look at the market share of different materials, it is easily to be seen here that the plastics are having the biggest market share. So either by themselves, or also I remind you that when you have paper and board or even metal packagings, then there is often a presence of polymer coatings. So polymers are also concerned in this type of packagings. And so not surprisingly, packaging is the main application of the polymers today, and it accounts for almost 40% of their annual production volume. And that's why it is quite important to look on the safety concerns of plastic packaging. So as was already said before, the plastics are not inert with the contact of food. Interactions occur, and those interactions are mostly linked to mass transport. In fact, when we look at the general laws of thermodynamics, we can see that when we have an atmospheric gas composition outside the packaging, which is different from the one which is inside the packaging, for example, for modified atmosphere packaging, then the concentrations will tend to equilibrate, as this is what thermodynamics are going to teach us. This means that there is going to be permeation of gas from outside the packaging into the inside, and the other way around is also true. This means also that when you have a technological adjuvant or a contaminant which is conserved in the plastic, then it can be extracted by the food, and we term this migration when you have those contaminants coming from the plastic inside the food. The other way around is, of course, true also. So you can have a number, mostly volatile molecules, which are contained in the food, and then they can be sorbed by the plastic. And then we are going to term these processes here sorption. Of course, the migration, this is our first concern, and this is a food safety concern, but not to neglect the two other possibilities. Permeation and sorption are often linked with food quality concerns, as they can decrease the aroma intensity, unbalanced flavor of your food, or even have a modifying effect on the packaging in itself. So, of course, let's come back to safety. So I am showing you here in the very scientific point of view, this problematic of mass transport. You have a contaminant contained in a polymer, and you have the food in contact of it. Of course, there is going to be equilibration of the concentration, and this is described by the fixed second law. This law tells us that the diffusion is in our field of application always the rate limiting step, and the diffusion, this is the kinetics, so the rate by which the transport is going to happen, and this is linked to the cohesiveness of the polymer, the size of the micron, and the temperature. But then you have also a second part, which is the partition coefficient, and the partition coefficient, which is termed here, is describing the equilibrium value. This is a convention, so this is describing how much of your contaminant is going to be dissolved in the end of the equilibration process in the food with respect to the part which is remaining inside of the polymer. The fact that it is termed like this means that when the value here is high, then you are on the good side, which means that the contaminant very much likes the polymer and doesn't like the food. So this is good. You have different situations then to manage here. The first situation, which is the best situation for any food safety manager, it is that you have a very slow process, so a low diffusion coefficient and a high partitioning. So it is slow and it doesn't go very thoroughly to the food. So there you have a little contamination. Then you can have a quick process, but still not very high affinity of the contaminant to the food, still an intermediate situation here. And then this shows you here that when the partitioning coefficient is going to be low, which means that your contaminant is liking the food, you have always a problem in managing your safety. And you have this problem when you have slow kinetics. And of course, you have the most concerning situation is going to be a very fast process and a high solubility of the contamination in the food. So these situations need to be evaluated, and this evaluation is on the ground of all the migration testings which are asked for by the different legislations of the world, and which are going to be explained in the presentation after me. So two different possibilities to evaluate. Either you do an experiment where you are going to immerse your strip of your polymer and then measure the concentration of the migrant in the food simulant. You can also use a migration cell and do the same measurement. The difficulty here is linked to the analytical chemistry because you will need to have very low limits of detection in order to, and very specific materials for analytical devices in order to detect your contaminants. And it is quite time consuming. The legislations does allow also the migration modeling, and this is quite a good news because as I told you before, the physical chemical background is very well known, which means that this can be calculated. The migration can be calculated, and it can be calculated especially when you know the different transport parameters of your system and when the interaction between the polymer and the food is neglectable, which means that your transport is following fixed second law. Here, the difficulty is, of course, the availability of the data of the transport properties. In this respect, we developed inside the SafeMat project a comprehensive tool of migration modeling, which is called FMaker tool, and it is an open source project. So you can find it here and in this link, and you can copy and work with it. This simulates the migration of any type of surrogate inside a food contact material, taking into account either existing databases of known diffusion coefficients or known partitioning coefficients, or very robust physical extrapolations, of these different transport parameters, always ensuring to have an overestimation, because the overestimation is giving us the assurance that we are on the safe side. Then you have, with this type of calculation, a very high throughput methodology, which can help you to have a lot of results in very short time. And we are able to scale this on a severity and criticality scale, which can then help you also in your decision-making process. Where the issues are is when we have strong interactions between the food and the packaging, which, for example, bring about the morphological changes of the polymer. I give you an example here on PLA, which is getting plasticized by ethyl acetate. So you see the glass transition temperature of the PLA and the quantity of ethyl acetate sorbed inside the polymer, and there is a quite important degrees of this glass transition. And also an increase of the crystallinity of the polymer. This means here the polymer is changing and its transport parameters are changing, which means that it is not described only by the thickened second law again. And then we need to evaluate in order to be sure to not make an error in prediction, for example, of transport properties. Aroma sculpting can be also a problem. This was ethyl acetate, and it is a very widely used aroma compound. And what is very tricky with the aroma compounds is that they are sorbed always in a synergistic manner, which means that when you have already a compound present, in the polymer, it's going to open up new volumes and help the other compounds to be sorbed inside it. And then you can come back to this type of situations of morphological changes. The second challenge I wanted to share with you is the plastics in the circular economy. In Europe, there is a very big policy driver in order to enforce this circular economy by favoring very much the recycling of post-consumer plastic waste. Ideally, this recycling would be a closed loop recycling with a very, very large number of cycles. This is something which is today accessible for glass bottles, for example, or metal packaging. When you are coming back to paper and board, there is limited recycling. It is quite an important number of cycles which can be done, but this is not going to be for infinity. And this limited recycling is even more true for plastics, as in Europe, you have only the PET bottles which can do several cycles, which means that the PET bottles can come and be recycled back to a bottle. All the other food packaging materials are concerned with downcycling, which means that when they are recycled, the second application is not a food contact anymore. The reason of this is, of course, the high contamination risk of plastics in an open post-consumer recycling because of contaminants coming from possible misuses, from cross-contaminations by the collection with non-food contact materials, and from sorting errors. So in the aim to be able to recycle back the plastic to food contact material, the EFSA is imposing specific processes, and you will need to show that you have regeneration and super cleaning technologies which are ensuring food safety over challenge tests. And the challenge tests are also asked for by the FDA, for example, here, which shows you what you will need to do in order to be sure that your cleaning strategy is then safe for being used by a consumer, for the plastic being used by the consumer as food contact material. From the evaluation and chemical analytical side, this is the, I think, trickiest challenge, because this means that we will need to evaluate always random unknown molecules. So non-targeted analysis of contaminants is a very active research field, and these random unknowns, this means that those are molecules, they are present, but they cannot predict it because they come from casual contamination because of misuse or the presence of a random contaminated object in a waste bin, a random contamination of the polymer processing equipment. So it is quite tricky to evaluate all those. There are confirmed risks for paper and for plastics. And here this slide is only to tell you that we were making the experiment. So just because you put your food inside of a virgin polyethylene pack, you are not on the safe side when you put it inside a recycled food container, as we were showing that this is not a functional barrier. You have almost no retarding of the migration of dangerous substances through the polyethylene inside the food. So in the European regulation, this NIAS problematic needs to be managed for the food contact materials and also for the recycled food contact materials. So in conclusion, I was taking you through the very physical chemical principles of the mass transport, which are the grounds of the safety evaluation of the packaging materials. And so here the good news is that this is almost known and the physics are installed and sure. Therefore, we can use modeling approaches for the evaluation of migration. And those model approaches, they are very valuable add-in where analytical chemistry is going to be very much limited, which means in situations where the risk assessment and the management of unknown substances needs to be done. So we can develop methods for the prediction of exposure to unknown substances. where you ignore your acceptable exposure limits. And this is especially true when you have molecules with endocrine disruption activity, and you need to take into account the cocktail effects. The assessment of migration and exposure below the analytical detection limits is also possible by calculation, and the assessment and design of functional barriers. But besides that, there is also other challenges we will need to raise to all together. It is the traceability of the recycled materials, the containers and the decontamination, the management of the cross-contamination during collection, sorting and recycling, and the analysis of the NIAS through the life of the container or the recycled container, taking into account the aging of the materials. With this, I thank you very much for your attention. And when you like a further reading, I can advise you to look on our online lectures platform on food packaging, and you find the link here. Thank you very much.